Okay. Alright, so here we go on to today's notes. So what we're doing today is called simplifying radicals. We're not solving, we're not evaluating, we're just simplifying. This is just a silly little cartoon to try to help with the analogy that I use for simplifying radicals. But before we can do that, hopefully you all have the notes in front of you. We're going to talk about some vocabulary. So you know what this is, right? This is called a square root sign. But you actually have another name for it. It's also known as a radical. So this is called a radical. And then the number underneath the radical is called the radicand. Now, we also have these kinds of square roots. These look a little different. These are called cube roots. So let's go ahead and write that down. This is a cube root. And basically a cube root is this. If I want to know what number times itself, so like a square root of 16 means what number times itself twice gives me 16, so you should know that that's 4, right? So a cube root says what number times itself 3 times will give me 8. So what number cubed equals 8? So you should know that 2 times 2 times 2 equals 8, or 2 to the third equals 8. So the cube root of 8 would be 2. So this is a cube root. This here is still called a radical. This is still called a radicand. This number here is called an index. It tells us what we're looking for. So, for example, in a cube root, it tells us we want to know how many times does a number times itself, or what number times itself 3 times gives us the number in the radicand. For a square root, we assume that the number is 2. It's not there. We just make that assumption. If it's anything other than 2, they have to give you an index and tell you what the number is that you're looking for, how many times you're multiplying a number by itself to get the radicand. So the index that we're going to, indices, because that's plural of index, that we're going to be dealing with this year are 2 and 3. You won't see anything higher than 3 this year. In future years, you will see higher indices. However, we're just dealing with 2 and 3. So that's just the basic vocabulary. Now, we have some information here about Ant Hill Daycare Center. So some of you, I'm sure, have babysat kids before, and you know that it's a lot easier to take them outside and play than it is to try to entertain them inside. So, plus, when you take them outside and play, your house doesn't end up a total wreck. It keeps things nice and simple at home. So, the other thing is, we're going to talk about if kids go outside to play, you want to use the buddy system, right? Most days you can go out in pairs, but some days you have to go out in groups of 3, and this is posted on the door using an index card. Get it? Get it? I'm clever. I know you're thinking it. Hey, I heard that. Okay, I didn't hear it, but I just thought it'd be funny to say that. Alright, so let's go ahead and start simplifying. In order to simplify this, what we're going to have to do is we're going to have to find the prime factorization of 56, which is why it was important for you to remember prime factorization. So I'm going to start with 56. I'm going to do the prime factorization of 56. So also notice there's no index here, which means that we're talking about the square root of 56, which means that the numbers can go out in pairs. So 56 gets broken down into 8 and 7. 7 is prime, so I'm going to circle it. 8 gets broken down into 4 and 2. 2 is prime, so I circle it. And 4 gets broken down into 2 and 2. And I circle those. So if I rewrite the square root of 56 as its prime factorization, I get 2 times 2 times 2 times 7. If I multiply that out, I should get 56. So 2 times 2 times 2 is 8 times 7 is 56. Now, like I said, since there's no 3 here, that means that our index is 2, which means that we can take numbers and kick them out of the daycare center or house, however you want to think about it, in groups of 2. So do I have any groups, do I have any pairs of numbers? The answer to that question should be yes. Good, that's right. So I have this pair of 2s. That means that can get kicked out. Now, what is that actually saying? Well, if I look at this and I break it down in a different way, I can say that what I'm that what this actually means is 2 times 2, right? So we can look at it a couple ways. The square root of 2 squared times the square root of 2 times 7, right? Square root of 2 squared, you should see that the square root and the square cancel each other out, and that leaves you with just 2, right? Or if you need to see it this way, it's really the square root of 4. What's the square root of 4? It's equal to 2. But that still leaves the 2 and 7 in here. Now, the 7 doesn't play with the 2-year-old. They can't go out together. You have to have pairs of numbers. So the 2 and the 7 are going to end up staying inside. But this pair of 2's gets kicked out. We see 1, 2 outside, one pair of 2's outside, and we're left with 14 inside. Now, some of you are going to say, so that's our answer? Or what do we do to get the answer? Okay, so let's talk about what this means. So we have the word simplify here. Simplify does not mean to solve. You cannot solve unless you have an equal sign. So simplify means basically what we're doing is rewriting it. We're rewriting this as this. So like when you simplify a fraction, it has the same value, but it just looks different. So what you could do is you could put this in your calculator, square root of 56 equals, hopefully you all remember this, where the square root button is, and then 2 times the square root of 14 equals, and you would get that that's the same decimal. They do actually equal the same thing. Now, that tells you that these have not changed value. So we haven't done anything. All we've done is rewritten it. So the second question that's been coming up is, well, why are we doing this? Okay, so when you get to geometry and algebra 2, you're going to be working with radicals more often. And if you always forever turn a radical into a decimal, you'll realize that something like square root of 14 is a non-terminating, non-repeating decimal, which means it's an irrational number, which means you have to round it in order to work with it. Unfortunately, that creates lack of precision in your answers. So you want to keep it in radical form and do the operations with it in radical form. Now, I don't know about you, but 14 is a lot easier number to work with than 56. So we simplify them because ultimately it's going to make it easier to do the work. There is a video here that you can go ahead and watch. If you choose to do that, pause me, ask the sub to put this in, substitute if you don't mind, and you can watch it. It's basically just going to run you through one more example like this, but I'm going to go ahead and keep moving. Sorry about the coughing. Alright, now when I'm looking at this, I can rewrite this as -5 times the square root of 112. 5 is not the index. If it's the index, it has to be written really, like, it's written little. Also, remember, we're only dealing with an index of 2 or 3. What is the index of this 112? That's right, it's 2. So first thing I'm going to have to do is I'm going to have to find the prime factorization of 112. So 112 is really 56 times 2. 2 is prime. 56, we just found the prime factorization of that. We have 8 and 7. 7's prime. 8 is 4 and 2. 2 is prime. 4 is 2 and 2. So if I look at this, I'm really looking at -5 times the square root of 1, 2, 3, 4. 4 2's. And a 7. Alright, so again, I'm going to do the same thing. This time, again, my index is not there, so the index is assumed to be 2. So I'm kicking out pairs. So I have a pair of 2's that I can kick out, and I have a second pair of 2's. Yes, that leaves me with no 2's inside, but that's okay. Remember when I kicked them out? I just want to see what got kicked out, how many pairs got kicked out. So I have -5 times 2 times 2 square root of 7. So again, let's reiterate. What happens is when they get kicked out, you have a pair of 2's. When they get kicked out, you have a pair of 2's. Each pair is represented by one number outside. Remember, because, again, this equals 2 by itself outside. We don't need the 2 2's outside, because if I say to you, what is the square root of 4, you would say 2. Not 2 times 2, you would just say 2. So then all I have to do from here is I can simplify this. -5 times 2 times 2 is -20. Square root of 7. So my final answer is -20 square root of 7. Again, all we're doing is rewriting it in a different way. Simplifying it, not evaluating it, not telling me a decimal. Decimals are going to be inaccurate as you go into higher levels of math. So we're laying the groundwork here for what you will do later. Not that we're applying this at this point, but we're just laying the groundwork. So for our next one, we want to simplify this. Now what do you notice the index is this time? That's right, our index is 3. So instead of looking for pairs, we're looking for, that's right, groups of 3. So they can only go out in groups of 3. So 96. All right, so 96 gets broken down into 2 times 48. 2 is prime. 48 is 6 times 8, neither of which are prime. You could have gone 2 times 24. At the end, sorry, truthfully, it doesn't matter how you do your prime factorization. Everybody gets the same prime factorization at the end. So if you take a different route than me, just make sure that you get the same answers at the end. So 2 times 4. 4 is 2 times 2. 6 is 3 times 2. So now I've circled all my primes. I'm going to go ahead and put that inside my radical. So I have 1, 2, 3, 4, 5 2's. You'll notice I always put them in order. It makes life a little easier for when you're looking for your groups. And now I'm going to go ahead and look for, since my index is 3, groups of 3. Circle this group of 3. Do I have any other groups of 3? That's right, I don't. So these go out, and the same thing happens like we had before. We have a 2 outside, cubed root of, this is called cubed root of, 2 times 2 times 3, which is 12. Now why is it when you kick them out you only see 1? Well, let's think about it this way. I'm looking at the cubed root of 2 times 2 times 2, which is the same thing as the cubed root of 2 to the third. Well, if a square root and a squared cancel out, then what do you think happens with a cubed root and a cubed? That's right, they cancel out. So it's just equal to 2. So our final answer for this one would be 2 cubed root of 12. All right, on to the next one. 2 more, and then you guys are going to do some practice. Now here we have a variable. Does not make life any different. We're effectively do the same thing. We're going to start with the number 250. So I'm going to go 25 times 10, 5 times 5, and 5 times 2. Sorry about the coughing. Probably annoying to listen to. So I have the square root of 2 times 5 times 5 times 5 times... Now x to the third is the same thing as saying what? That's right, x times x times x. My index here again is 2. So I'm looking for, am I looking for pairs or triplets? I'm looking for pairs. So I've got my pair of 5s, and I also have a pair of x's. So with the variables, it doesn't work any different than it did before. You do the same thing. And I'm left with what inside the radical? I'm left with 2, whoa, pen, 2 times 5, sorry, give me a sec. Let's try that again. I'm left with 2 times 5 times x inside my radical. Outside my radical, 5 times 5 is 25. The square root of 25 is 5, so I have a 5 outside. I got a pair of x's, so I have an x outside. So this equals 5x radical 10x. So our answer is 5x square root of 10x. Hopefully that made sense. And our next one. Hopefully you'll get annoyed with writing out all the letters soon, because that'll jump us into the next part of the lesson. 200 gets broken down into 20 and 10. 10 is 5 and 2, both of which are prime. 20 is 10 and 2. 2 is prime. 10 becomes 5 and 2. So when I write out my prime factorization here, yes, you're going to run out of room. I know that. It's intentional. 1, 2, 3, so I have 3 2's. So there's my 3 2's. Trying to put dots in between is not easy on this. Times 5 times 5 times A times A times A times A times B, 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 I'm going to erase this a little bit. I know you can't on your paper probably, but I can on mine. Come on, pen. Times C times C. Okay, this time my index is 3, so I'm looking for triplets. I got a triple of 2's. I got a triple of A's. I got a triple of B's. All these things are going to go out. And now I have on the outside 2AB cubed root of 5 times 5 is 25. A, and I didn't lose my C's, and C times C is C squared. Now, remember that, please, because X times X does not equal 2X. Remember, X times X equals X squared. That will be important on the practice problems, so don't forget that. Remember, you can plug in the number 3 here and prove that. 3 times 3 is 9, not 6, right? So our final answer here, hopefully you don't hear Jazzy calling me in the background. My final answer here would be this. Now, that takes us to this, the your turn questions. I need you to go ahead and do those now, and I'll be back with the answers in a little bit.